Hello and welcome to my video, lesson 2.2 on Intro to Permutation and Factorial Notation. Alright, so we're going to look at this in a second. I just wanted to put it at the top, but let's take a look at a question here first. And then hopefully once we do the question, it can kind of become a little bit more obvious how factorial notation is actually useful. So Connor, Mac, and David are lined up at a grocery store. Connor McDavid. How many different ways could they be lined up? So 1, 2, 3 positions in line. I'm using our counting method, fundamental counting method here, or counting principle. So there's 3 different positions in line. If you think about it at first, there are 3 choices. Connor could go first, Mac could go first, or David could go first. Once I choose someone, after that point, there are only 2 people to choose from. I choose someone else, and now there's only 1 person to choose from. So, 3 times 2 times 1 is 6. And this is the number of different ways that they could be lined up at the store. Now, in this very simple case, it's really straightforward and quite easy to use our fundamental counting principle to solve this question. But it becomes more and more challenging once you have some bigger sets. So multiplying 6 numbers together, not as much fun. So is there some way that we can write this more easily? Well, there is. This is where our factorial notation comes into place. We use our first number, and we write it with a little exclamation mark, which is the factorial symbol. And that means, or that is the same thing as writing 3 times 2 times 1 equals 6. So 3 factorial equals 6. Okay, how can we generalize this? Well, if we have a 3 here, or whatever the number is, maybe it's a 10 here, then our first number in our multiplication set is that number, but our next number is the 10 minus 1, right? Or 9. And the next one's 8, 7, 6, 5, 4, 3, 2, 1. So factorial notation is basically multiplying that number, and it has to be a whole number. It has to be a natural number, which means not 0, and it has to be, so 1, 2, 3, 4, 5 to infinity, but it has to be a whole positive number, so natural number. So that there is the example and explanation of factorial notation. So with that in mind, can we solve these questions down below here? These 3. If you can already solve those without a calculator, go ahead and try. I'm going to maybe just give it a little bit more space in between. Okay, so if you can pause the video right now, try this out, and then press play to see if you get the same answer I do. Right here. Okay, so let's go through and try this out. Sorry about that. So 4 times 3 times 2 times 1. So I'm just splitting it up. If I don't have a calculator, this is the best way to do it. So 4 times 6, so 24. Okay, this next one, I'm going to split it up this time, but you're going to notice something. Well, I'm going to split it up part way. I don't want to split it up all the way. ... You guys can see how that would continue. And this is divided by 25 times 24 times 23 times 22 times 21 times 20... ... And you can see how that would continue. So what happens here is the top and the bottom can cancel out all of those different things. So you're left with a 1 at the bottom and 26 on top. So this equals 26. Okay, so notice how that actually becomes a lot easier than even putting that in a calculator. Okay, and our last example question here, we have 3 factorial and 7 factorial. Now we know with our rule we can simplify this down. So I'm going to write 3 times 2 times 1 as that first part. And that top part, the part I circled, the 7 and the 6 factorial, they cancel so that there's only a 7 left on top. So 6 times 7, so 42. And maybe I just want to show one more option here. I'm going to make it question number 4. You can still do the canceling thing if you have a number that's less than it's not just one different, but it wouldn't cancel all the way. So this would be 5 times 4. All right. Yeah, so I hope this video helps you understand an intro to permutations and especially factorial notation, as this is very, very important for our next topic. Good luck.